An ellipse is a conic section formed by cutting a plane in a cone that is not parallel to the base. So if you introduce a cutting plane here, what will it form is a shape like this, and that is an ellipse. So let's identify the parts of the ellipse. So we have here the vertices. So we have V1 and V2. You also have the co-vertices. So your W1, W2, and you have the foci. So you have here F1 and F2. One special characteristic of an ellipse is that if you have a point here, let's call this point A, then you connect the foci to point A, then you have another point here, point B, connected to the foci. So one special characteristic is that if you add the points connecting the foci, for example, we have AF1 plus AF2, this is equal to BF1 plus BF2. So the sum of this is equal to sum of this. Any point in the ellipse, if you add the length of the lines connecting the focus, those lengths are equal. So if you have here C, is also equal to CF1 plus CF2. Now, the ellipse could either be horizontal, so with reference to the major axis. So this is your major axis, the longer axis. So this is your major axis. So major axis contains the vertices and the foci, while the minor axis contains the co-vertices. So vertices, so ellipse by orientation can either be horizontal or vertical with respect to the major axis, and the vertices or the focus could either be located or the center. So we have the center here. So this is the center of the ellipse. So the center could either be located at the origin or at HK. So if we have ellipse with vertex at the origin, so if this is horizontal, you have your equation x squared over a squared plus y squared over b squared equals 1. So your a here is the distance from your center to vertex. So this is your distance A. Your B is the distance. So A is here. So this is the distance A. Your B is the distance from the center to the co-vertex. So this is your distance B. And your C is the distance of a focus to the center. So here, when your vertex is located at the origin and the orientation is horizontal, you have x squared over a squared plus y squared over b squared equals 1, where a is greater than b. Now, here, when you have an ellipse on vertical orientation, you have x squared over b squared plus y squared over a squared equals 1. In this case, here b is greater. So your b is here and your a is here. And here is your c. Now, if you have an ellipse with center at HK, or here, like this. So this is not vertex but center. So center at HK, you have the equation x minus h squared over a squared plus y minus k squared over b squared equals 1. And if you have vertical orientation with center at HK, you have x minus h squared over b squared plus y minus k squared over a squared equals 1. So let's try to solve an example. So let's say we have the equation of nine x squared plus 16y squared minus 126x plus 64y equals 71. Now, let us first identify the values of a, b, and c. So we cannot determine the value of a, b, and c because the equation is in general form. Therefore, we have first to convert the equation to standard form. So here, we can do this by rearranging the equation. So group those with variable x here and those with coefficient y here, then 71 is stay here, or the constant. So we have 9x squared minus 126x plus 16y squared plus 64y equals 71. Now our goal here is to convert this in a form of the standard form. So therefore the x and y must have a coefficient of 1. Therefore we have to factor out the numerical coefficient of x and y. Therefore we have 9 times x squared minus 126 divided by 9 is 14x plus 16 times y squared plus 4y equals 71. Now, just like what we are doing with circles and parabola, we complete the square in order to identify the center of the ellipse. So you have 9 times the quantity of x squared minus 14x plus 1/2 of 14 is 7 squared is 49 plus 16 times y squared plus 4y, 1/2 of 4 is 2 squared is 4 equals 71. So plus, so what you do on the left side, you will also perform on the right side. So we have 9 times 49 plus 16 times 4. So simplifying, we have 9 times x minus 7 squared plus 16 times y plus 2 squared equals, so this is 71 plus 9 times 49, 71 plus 9 times 49 plus 16 times 4, we have 576. So now that we have this equation, the goal here is to make this constant equal to 1. So we can do this by dividing the equation by 576. So we have 9 over 576 is 64. So x minus 7 squared equals 64 plus y plus 2 squared over 16 over 576 over 16 is 36 equals 1. That gives your standard equation. Now, your vertex is 7 and 2, while the values of your A is 64, B, A squared is 64, B squared is 36. Therefore, your A is equal to 8, your B is equal to 6. And here notice that A is longer than C. So we have A squared equals B squared plus C squared. Now, your C squared equals A squared minus B squared equals 64 minus 36. So that is equal to 28. Therefore, your B equals square root of, or your C is equal to square root of 28. That is equal to 5.29 or 5.3. Now that we already identified the values of A, B, and C, we can therefore conclude that the ellipse is having an orientation of horizontal. Why? Because the denominator of x element is greater than the denominator of your y element. On the other hand, if the denominator of your y element is less than the denominator of x element, or the denominator of x is less than the denominator of y, your ellipse is vertical because A is always greater than B. So it falls in this category. Now we can draw the graph of the ellipse. So we have the vertex or the center, not vertex, so the center 7, 2. So we have here 1, 2, 3, 4, 5, 6, 7, 1, 2. So this is the center of the ellipse. So the value of B is 6. So let's count 6. 1, 2, 3, 4, 5, 6. So it's 8. So your covertex 2 has the coordinate of 7, 8. Let's count 6 here. 1, 2, 3, 4, 5, 6. So this is negative 4. So the covertex 1 has coordinate of 7, negative 4. So for A, so let's count 8. So we have here negative 1. So this is the coordinate of V1. So your V1 has coordinate of negative 1, 2. Let's count 8 here. 1, 2, 3, 4, 5, 6, 7, 8. So this is 15. So your V2 has coordinate of 15, 2. And your foci F1 and F2, let's count 5.3 to the left. 1, 2, 3, 4, 5.3. So you have here F1 1.72 and your F2 1, 2, 3, 4, 5. So this is 8, 9, 10, 11, 12.3. So you have here F2 having coordinates of 12.3 and 2. So let's connect. So this is your minor axis, this is your major axis, and this is your ellipse. So this is the graph of the ellipse with the general equation of 9x squared plus 16y squared minus 126x plus 64y equals 71.